So, I won't make any announcements or some sort of hiring stuff for the company I'm working at. I will talk about patternplate. That's a project I'm doing at Schrader, and that's it. With the some notes about me. I'm a front-end developer. I'm working at Schrader, and I'm the initial author of patternplate. If you want to see what I'm doing, you can find me on Twitter and GitHub under the very obvious name of Mario Nebl. And to give you some context, what all this that I will be showing is about is the following. The principle for invention I use to decide if I want to start with a new side project is enabling. And the idea behind this is I want to build stuff for my coworkers, clients, and my clients' clients to do things they could do they weren't able to do before. If you don't know what inventing by principle is, I recommend a very good talk by Brad Victor, who's talking about the benefits of having a strong principle for what you're doing as a programmer. So, what I will be talking about, what you've done already is it's me, Mario. We are currently at this talk. I give a very brief primer on atomic design because you have to have a slight notion about atomic design to get what the software we built is about. Then I mention an emerging trend in the front end departments that's called living Styleguides. I try to keep this short. And finally, we will talk about what patternplate actually is and what it can do for you. So this talk is done too. What's atomic design? Atomic design is coined by Brad Frost. And basically, it's a way to describe your front end in a modular fashion. And what it's focusing on is it wants to teach everyone in a project and everyone who is involved in doing websites or the website that the project will lead to talk about the same things with the same language. What atomic design uses to achieve this is it tries to modularize your front-end components in some major categories. That's atoms, molecules, organisms, templates, and pages. And the complexity in this row is rising from the very basic building blocks to entire pages. So atomic design is basically this. And what's the good thing about this is we are doing this already. We are building complex and giant websites with very, very small building blocks called HTML tags. And then we are strapping CSS on it, which is global. And we are strapping JavaScript behavior on it, which is not so much global, but it's modularized. And it's not as modular as the actual content we are drafting. A short mention of living Styleguides. What are living Styleguides? Living Styleguides are a way to replace the current PDF Styleguides we are using to specify how a modern front end should look like, how it should behave. Living Styleguides, in contrast to PDF Styleguides, try to evolve with the project they try to document. they can show things PDF style guides can not document, cannot show. That's animations, transitions, and so on. And as a matter of fact, living style guides are great to document atomic design projects. Why is this? Atomic design projects tend to branch out quite a bit. They tend to place the components that you as a front-end developer will be building in these categories like atoms, molecules, organisms, and so on. And you have to have a way to show this and to document it, and for everybody involved in the project being able to access these components under their correct names. Style guides, because they are web applications, tend to make this a lot easier than the former PDF style guides, which in effect are just print documents viewed on a computer. Now, to patternplate. What is patternplate? And if you go through this list, you can see patternplate has the problem that it has an identity issue. It's a development server. It's a living style guide interface. It's a component dependency manager. I tried to show this. It's a customizable build tool. And last but not least, it's a universal React application. To go back, and it's open source. This point somehow made it on this slide. And you can see it on GitHub under the Sinnerschrader GitHub account, and poke around in the code I wrote. I promise there's a next branch soon, and it'll get better. Next is a demo, because I know all this talk is hard to grasp, and you want to see the goods. So what we can see here is the patternplate web interface. On this side, you get a navigation that's based on a directory structure in the project that's lying behind this. The project is a Git repository, and you find in a given folder I show later that there's exactly these folders: home, basics, atoms, molecules, organisms, templates, pages. And there are other folders that are named headline, icon, link in the atoms folder. Now, if I click on, say, headline, I get this demo, and this is actually a web view, an iframe of the demo contents for this pattern here. And I get these tabs that allow me to display markup for this pattern, that allow me to display the styling that's applied to this pattern, and that allow me to show the dependencies this pattern has. In this case, it's only one dependency. It's the root. Root can be found here. So nothing there yet. Now, if I jump back to headline, I show you how this comes to be. I hope this is big enough. Unfortunately, one cannot make the file tree view in Atom bigger, but I hope it's enough. Here you can see this is my patterns folder. You find, as I said, the directories atoms, basics, molecules, organisms, pages, templates. That's directly connected to this navigation structure. And in there, in atoms, I find the headline atom, and it consists out of these files. What's very important for patternplate to work is this pattern.json file. It's a direct steal from package.json, where I can denote what's the name of my pattern, what its version, and most importantly, what are the dependencies this pattern has. And what this does is it gives me the root component from basics root, and this is a reference inside of my pattern tree. So what I get from this is basics root, where other code lives. And now this pattern, the headline atom, knows the contents of root under the name of root. This leads me to the possibility to import the less file contents of root under this name in the less file. The JSX template doesn't make use of any code in root, so there's no import. The same for the demo. But here you can see what's this about. Next to the pattern JSON, there's, and I stepped through them already, styling I can attach to headline in a less file. A template, which in this case is a complete React component, which will get rendered on the server side just to produce my HTML. And demo code I can use to make a difference between my library code, which in this case is this index file, and the demo I want to show in my living style guide. That's an important distinction to make it easy to show variants of a pattern, visual variants or content variants that should not live in a given build artifact I want to produce with the living style guide. To show you the actual power of this, I step into a bigger component. It's an organism called Newskachel, and this produces one of these tiles, which consists of a not so small amount of other patterns. If we inspect what this code behind this looks like, we'll see in organism's news tile, index.jsx, for example, that this news tile produces this HTML output. Now we can see another version of the JSX templating engine. We don't need these boilerplate React classes. We can write just plain JSX, and patternplate will try to build a dummy React class around it and produce HTML anyway. So what's this doing is, and there I can see a code smell. It's building this kind of teaser, and it's using a headline, but it's doing this in plain HTML. But as I saw already, there's the headline atom, which should do it. Should do this fast. So, and if I look at the demo, I can see, nah, that doesn't look right. So what I try to do is I use our actual headline atom to keep this dry and nice. So the first step I have to take is I have to let newstyle know that it has a dependency on headline. So as I have shown already, I can write, and I'll take the obvious name of headline, that I have a dependency that I want to have on the name of headline, and this should point to atom's headline. And now I'm capable of doing this. I can throw this out and use. And now I'm following some conventions here because JSX needs, as you all know, uppercase names to know that this isn't an actual HTML tag but a custom component. Under the uppercase name headline, I set a tag name to match the H3 we had before and give it a title prop and send my title prop from the upper component, from the news tag component, into it. Sorry. Thank you. So, and what I get from this is now the actual markup from the headline atom is used. The correct stylings are applied, and in general, I can benefit from the fact that I'm defining what a headline should look like at one place only, and use it throughout my entire pattern tree. Back to the slides. To sum it up, what patternplate can do for you, and I hope I transported or told you or showed you what this really means is there's a full dependency tree for all the files you're keeping in this pattern tree. You have patternplate knows at every point in time which less files are including which, and what's the relation between your React components you're using to produce markups. So I'm capable of finding orphaned leaves in the tree and telling you about it so that you can throw out, say, unused code. There's the distinction between demo and library code, so you can show your customers or other project members variants of your components without duplicating code in your actual artifacts. It has this presentation of front-end components I showed you in the demos, which is a powerful way of letting everyone that's not in tech know at what status the project is, what is ready to be consumed by another tech worker, and so on. It uses JSX templates, and it's capable, and sad I cannot show this today, of the creation of arbitrary build artifacts, meaning I could produce handlebar templates based on these JSX templates because I have a build framework in the server behind this. And we already did. It's not just banter. So what's on the roadmap? E.g., aka what's not done yet. We have no full static export of the client. The front end you just saw currently needs a node server behind it. Needs to make JSON calls against the node server, and I want to change this. I want to, because it's a universal app, I want it to live entirely in the client if I want so, if I need to. So there will be a full static export of this client application. I want to do a full integration of stateful React components. What you just saw was I'm using React components and JSX to render the markup. But in most cases and for most projects, we still are using no React on the front end. So you write other JavaScript on top of this. And for this reason, there's no full integration of stateful React components. Say I write one of these index.jsx files we just saw, and create the client-side JavaScript based on this too. A very important point for me on the roadmap is currently we have no CSS modules in a living Styleguide. I'll change this, meaning that whoever wants to integrate what we are building inside of a pattern plate doesn't have to bother or to know anything about the class names used in these components, and just can pick the artifacts we are producing and get, if he uses our CSS, get the correct styling right out of the box. Next up, QA. Yeah.
How are you supposed to use this project? So, I mean, so you have this patternplate project. Do you check it out and build your project on top of this? or is it more like an external dependency that you can maybe include, and then you build your project and can handle versions of this phases?
The cool thing is you can do both.
Okay.
You can just check out patternplate as it is from GitHub and throw your pattern tree in it and a render, and you will be able to build whatever you want. Or you can install it as a npm dependency, execute the binary that is shipped with our npm dependency, and be ready to go.
Do I have to use less, or can I use plain CSS or Sass or something?
You definitely can't use plain CSS. What we're doing in the background is all the source files go through a chain of transforms, and I haven't come around to write a Sass transform just yet, but it should be trivial. And in the meantime, it's plain CSS or less. But if you would be interested, you could just write a known Sass transform.
You said that it is a build tool as well. What are the artifacts that it produces? Is it just plain CSS? Because you said the markup is just rendered on the server, so there are no React components coming out of it, or?
Currently, we have two major build tasks. One of it produces plain CSS and HTML snippets and a big browserify bundle. That's for the more for smaller use cases, I guess, for simple sites like landing pages or such. We have a second build task called Common.js. This produces the entire pattern tree and basically rewrites the path, the include paths in the source files. So what it does is it will put the React components in a subtree in the build artifact. It will put the less files in a subtree and the JavaScript files in another subtree, and you'll be able to include from another project that has an own build setup. You will be able to include the styling in your own less or CSS if you want so, and the React components are fully usable for your own JavaScript front-end side JavaScript if you want to. What you have to keep in mind is you can't test any stateful behavior in patternplate right now. So you could write it in patternplate and use it somewhere else, but I guess that's not a kind of workflow you really want.
How many projects have you built with patternplate, and what did you learn about it, and what did you learn about working with different people on patternplate in a project?
Personally, I've built two projects with patternplate. I guess we have about 7 projects in the pipeline. That's in Ostrada that are based on patternplate. What's interesting is also what's interesting about working with other people and working, for example, with the designers on a project is also we have this very clear way to name things, to put them at a place, and now they should be called like this. They invent new names for things that are already named all the time. And what I'd really like to do is to give them the possibility to edit it right in patternplate, so they can have a say on the names without me having to learn them all the time. Yeah.
What do you think is the greatest benefit of using patternplate? Speaking for yourself.
Yeah. I guess the greatest benefit in a project is that you can show all the tiny little bits you are building to produce something bigger up front.
Yeah.
So there's not always the question or this conflict between a proper architecture in your front end and showing something very quick. I can build all these little building blocks, give it to my project manager and say, see, we are actually working on this project. There is progress. There's project and you can look at it.
So it's much about the visualization of the
This,
interface. And
yeah, that's one part. And the second part is the dependency tree for all source files. This allows me to actually perform code modding on an automated fashion on the whole tree. Whereas as long as we don't have a dependency tree for less files examples, it's really hard to know what's actually used in a project.
get code and so on.
Yeah.
At the risk of adding to the identity crisis, could it be used as well for documentation for React components?
Definitely.
Yeah.
What patternplate currently is learning, I'm working on it, is producing more than one result on the front end based on one source file. So say you wanted to you want to write JSON. I could render it as a tab in the front end, and if I want to, I could use the prop types to generate a fair amount of the documentation automatically.
Yeah.
Or if you wanted to combine it with TypeScript, I could use the interface definitions. It's all open.
That JSON file looks like about JSON or a package JSON. What about versioning, GitHub repos, and all that other yada yada?
Yada yada.
That we imply when we see these files.
Dependency management, yada yada. What currently
I tried to dumb it down.
yeah. What currently isn't possible is having more than one version of a pattern in one tree. So that's on the roadmap too, and I guess we just keep them in the tree. And what frankly isn't planned is some sort of registry. I don't want to, personally, I wouldn't want to repeat the errors the browser Bauer made and use GitHub as a content delivery network. I guess that's too slow. It doesn't work very well, and I would focus to not pay on the identity crisis of patternplate on these local pattern trees. So in the foreseeable future, there won't be any kind of pattern registry or something like this.
No, about the registry, but if I have a bigger project with a little bit more developers, then you have these like kind of designers who start coding are pretty good at it and will extend stuff like this. So I've always found the npm git mechanism was very nice for this as well, to spend a repo for a little element. Do you plan on extending this maybe? Not as a registry, but as an endpoint. So one molecule could have an own registry, maybe if it's a little bit of a bigger molecule. Probably not a molecule, but...
I guess what's currently possible already is you could have more than one pattern tree. So you could just e.g. use Git subtree, join them together, and you would kind of have what you're describing. What we see, the roadmap is open to amendments from the public.
I can add something to your roadmap, yeah.
You can send a pull request.
To the roadmap, yeah.
Yeah.
It's really important what we saw in recent projects was the fact that if you work with patterns and some days later a designer said, oh no, we don't want this button to have round edges, we just want it to have this, sharp edges, then you can just figure out over the dependency tree which components will be influenced by your changes, and it's a calculated risk to change major components, and not it just doesn't just happen. You can calculate what you will break probably.